Hello everyone, good evening, and I hope you guys are fine. Welcome to day 3 of Bootcamp Machine Learning organized by GIRLSCRIPT Chandigarh. I'm Tamanna Bansal, and our mentor for the session will be ANUSTUP Mukherjee. He is a former lead engineer. He's a computer vision engineer at Dark Horse, and he is a former he's a former he's a former researcher at IIT Patna and at IIT Bombay. And I hope that you guys make the most out of it. And thank you for your amazing feedbacks of the last video. It was really good, guys. And without taking much of your time, let's get started. Now I would like to invite Sir. Just a minute. Okay. Hello, sir.
Yeah, hi. Yes. So any questions from yesterday session to be handled first?
Uh,
Any questions?
we had one question. Like
Yeah,
it
sure.
will be better if we handle it during the question time maybe at the ending
Okay,
question round.
sure.
It will be
Okay,
good
that's
that time.
great. Yeah. So let us start with today's session. So today will be mostly a project-based work. Okay, because today we are completed with some understanding of basic machine learning algorithm. Obviously, linear regression, logistic regression, and I guess yesterday we covered linear, logistic, and yeah, decision trees, right? So apart from that, today we need, and yesterday we covered also OpenCV and a very short project, or very short project out of OpenCV, that is image cartoonizer, how to cartoonize your own image by using some inbuilt OpenCV functions, that is called median blur, Gaussian filters, I guess, yeah, any filter and the blurring techniques. That's it. As well, we made by helping decision tree, by using the power of decision tree classifiers. We made a very short project that is called weather prediction system, right? So these are the two things, okay, that we implemented yesterday. So are you clear, everyone clear with the yesterday's concepts? So just if you are clear, and then you just shoot the questions, keep on shooting the questions on chat section. So let us start with today's session. Okay, so today we will be starting with a project, again an OpenCV project, and this is a very interesting project and something out of bound. Why something out of bound? Because everyone speaks like something that pose determination. That is, if you want to detect anyone's pose, that can be only possible by using a advanced deep learning techniques. That is pose, that models are specifically called as the PoseNet models. Right, PoseNet model is the way out to detect a human pose. Today we will deploy it by using an OpenCV. I guess many of you will be thinking, how can it be possible? So let's see with a single script that how can we make a pose estimation model, that is you are passing a image, or you are simply by the help of your webcam you are running the script, and it will be estimating your pose. That is an important project. So today's first project is pose estimation by the help of OpenCV, not TensorFlow, not any so-called deep learning model, because I have found this thing over YouTube or many other places. Everyone is thinking to deploy this kind of things by using either the power of TensorFlow JS, or by the power of TensorFlow, or by the power of advanced deep learning. This is a way out. Why? How can we do this by a simple of OpenCV? Right. This is a very unique project. So let us deploy it. Let me share my screen. And you guys, I guess, understanding. And after this project, we will be starting with another left with algorithm, importance part only. That is the only deep learning CNN models. We will be making it. I am trying to make some project out of it. Okay, and yeah. So okay. So let us start with today's project. Let us start with today's important project. That is, the project name is again post detection, or post detection. Could you say the algorithm used for face recognition in OpenCV library? Okay, I will be handling on all kind of questions at the end, right? Because today is a project day, so let us complete with some amazing projects. Okay, so like, or keep on shouting your questions. I will handle everything. Okay, I will handle everything. So yeah, so let us start our project. The detection is again pose detection model. Pose detection model. If you want to detect anyone's pose, pose detection is again Something like just a real life example. What is a real life example? Nowadays, during the time of lockdown, especially, we all are working from home and we are sitting in any posture, like this, and like this. Any posture. I used to do like this, obviously. I guess everyone doing this because we are simply laying down in our bed and working in my laptop. Okay, so that is actual scenario during the time of lockdown, and because this lockdown, a class of people is like very much happy who are the therapist, like who are the physiotherapist, because after this lockdown everyone will be coming with this, oh my god, my waist is spinning too much. Why? Because we are not sitting in a proper posture, we don't know what is a pose to sit, and that's why we are going to a physiotherapist for a checkup. Okay, I need to remove this pain. So this is the actual scenario. So I guess everyone might wonder, like, if there is something that will be telling me what is my exact pose, there is something, right? Like Jadoo of Krish movie, right? Something like that. Like if there is anything that will be telling me about a perfect pose, right? So yeah, there is OpenCV. Okay, yeah, there is pose. Actually, the model is PoseNet model, but yeah, there is OpenCV. I know OpenCV, so I can make this kind of project by OpenCV. So this is the main background of this project. Why I'm telling background? Because you guys will be deploying this project on resumes also. So yeah, during the time when you are writing these things in the resume, you need to or when you are presenting this kind of things to your recruiter, you need to also tell about the entire thing or entire background, right? So today's project is again pose estimation model. This is the background of the project. So without wasting more time, let me open our explanation ground, that is the playground called as paint. So the project name is again uh, pose estimator, pose model I'm writing for now by using OpenCV computer vision project. Okay, so this is the name of the project today. So yeah, so how can we determine anyone pose? How can we determine? How our human brain determines anyone pose? Again, just follow the steps how I am approaching to make this project. This is my problem statement to detect anyone's pose. Now comes the implementation part. So what you need to follow, how I am solving this project, right? So how I am solving this project, the first question that is striking in my mind is how human brain detects anyone's pose. So yeah, how human brain detects anyone pose, the logic is very simple. Like someone brain used to work a basic classification model at its backend, or human brain. Like obviously human brain have some sort of backend. So it used to use something that used to classify it in between some groups, right? So what are the groups? It's simply like if someone need to, like, you are studying something. So the obvious pose of studying is sitting in a chair and table and studying, right? But someone is lying on his bed or her bed and the person is studying, right? So that is not a correct pose. So this is a very basic classification thing that our brain understands at a very initial instance. Okay. So now my brain, now I grown a question. Okay, so how can we understand now how the brain is classifying in between these two cases? So first thing is that in what posture the human is, or what is the case of the human. That means human is studying. Okay, for studying this should be the perfect pose, and this is not to be a perfect pose. Now I am grown with a question. Now how to determine this is the perfect pose for studying? So you need to think like, okay, while studying, what is your posture? You are sitting in a chair. That means your posture is a sitting posture. Your nose, sorry, your necks or your hands or your ankles will be in certain position, right? So now a question comes in my mind. Okay, the brain understands how everything is placed. That is, while I am sitting, what is the actual placement procedure of placing my legs, placing my body, placing my hands, everything, and what is no, what is a wrong. That is the same thing. So at a very deep level of our problem statement, what is a very deep level of our problem statement, or you might say at a ground level of the problem statement, we need to understand the parts of the body. That means I need to detect with the hand, I need to work with the knee, I need to work with neck, right? So I need to detect in which angle it is being placed. So again, at a very ground zero level or 0 to 0 level, we need to detect at what angle everything is being placed, right? But at what angle everything is being placed. Okay, so now anyone might tell y angle. I can also detect anything else because y angle, because see, it is real time case. Suppose you are walking in the street, walking in street, and you might suppose you are simply cycling. Okay, you are simply cycling, and you have to bend in a road. That means you have to take a cross. That means in this way. Suppose a U-turn road. I obviously will be slowing down your speed and simply taking a U-turn. Otherwise, you will be feeling a simple logic of circular motion. Otherwise, you will be feeling if I am at a high speed, then the angle that will be made by me and the cycle will be very less. That is called as a tilt angle, and I might fall. A very basic logic comes from physics. So obviously, angle is the most important thing to understand anything real life. So here, pose estimation is also anything out of real life. So I need to detect how a object is placed in 3D. Then I need to detect in the basis of the what angle it is actually being placed. So now your problem statement is at a very ground level, very much clear to you. So you understood. Okay, I need to write a OpenCV logic that will be first segmenting out the parts. That means neck, hand, etc., etc., and detect out its angle. Based on it, it will be telling or simply drawing a line which will be telling the human's pose actually. So this is my very basic thing. So now the question comes like something like this. Like this is a human, and I am applying a post detection model. After a post detection model, it will be drawing something like this over the human. So it is detecting the human is standing at a very like straightway pose. So this kind of thing we need to implement, right? So now the question comes in your mind, that is my problem statement is now crystal clear to me. What is the next step? So data collection, so we will be taking from real time. That means whether accessing my webcam, otherwise I will be simply taking any image to detect a pose. So data collection is not a big issue over here. So machine learning mantra 1 is done. Now mantra 2 is the exploration of the data. That means how to collect out the attributes. That means what are the attributes we need to work. Obviously hand or any neck or etc., etc. So you need to make very short functions individual. That means a function to detect out the nose, a function to detect out the objects that things may come into mind, right? So yeah, take it as an example for exploratory data analysis. So okay, this is the way out that we might do. I need to detect out each and every segmented objects out of it. Okay, so machine learning mantra 2 is done. Because here there is nothing a big step of feature extraction. We will be directly writing out the logic. So up to this, the problem statement I guess is very crystal clear, and how we are what will be the step one of our approach, I guess is very much crystal clear. So how we'll be implementing this thing in OpenCV? Let us start. Okay, so yeah, so let me open the code base. Yes. So first, like every time, like yesterday, as if we will be starting with the implement or calling the OpenCV simple OpenCV package. I guess the screen is visible to everyone. Though if it is not visible, just I am zooming it out or zooming some more. Okay, so let us start with the OpenCV part. So first we need to, since our library is OpenCV, so we need to call the OpenCV as CV2. You can just store, I at the very first session I told like import numpy as np, import matplotlib as plt, right? This kind of things you can store any variable. If you don't need to call the entire package every time in your code like matplotlib.plt show like that, then you need to store the entire package into a variable like plt, np, pd, etc. The same thing also we can do out of the OpenCV, CV2 as CV, because 2 we may miss. Or if you're not doing also, no, not an issue, right? The numpy is again because why numpy is important at each and every stage of computer vision, because the numpy is dealing with the arithmetical things as well as the multidimensional array, dealing with all kind of number wise inputs, right? So why we need number in the computer vision? Again, I'm repeating the logic because every image is decoded at a background in some numerical format, because machine doesn't understand human and everything. It only talks in the language of some numbers, right? Because how a machine understands, again I'm repeating the logic of facial recognition, how your machine reads your face, simply calculating the distances in between the two eyebrows or eyebrow to lip, lip to nose, like this, simply for coordinate based logic. Okay, so it is simply, it will be forming an array of numbers, right? So to deal with that, we need numpy and argparse. Argparse is a simple Python library that if you need to work in a command line interface, CLI, or if you don't want to directly input your data in the script, suppose you need to input in the CLI, then you need to take the help of this particular package, because it is specifically passing the data in as an argument. So hence we are simply using the argparse. So first we will be writing some arguments, like if I'm using this argument input, then it will be something like, if I need to run this script, python openforce.py dash dash input, then the image path, right? That means if I need to input the image, then it will be calling the image in the script by the help of this particular argument. If I need to see the threshold value, I guess yesterday's session I explained about the threshold. What do you mean by threshold? If you need to call a images threshold color values, then how to visualize it? Suppose in the command line I will be writing python openforce.py dash dash threshold, and then simply it will be passing the image, and simply it will be passing the image to the script by the help of this particular argument, and again done. So same way I have first specified some kind of argument. So if anyone feel like it is very much difficult, then simply go for direct data input. Anything you can do. It's not an issue, not a case of our case, right? So now the question comes, it is all about argumentation. Now the question comes of defining the body parts, like what kind of thing I need to define. So before coming to this part, many of you might feel like why I'm defining it very early, because we need to define each and every object that I am going to detect. Right, I am going to detect a human's neck, left shoulder, right shoulder, elbow, our ankle, our knees, our legs, everything I need to detect. Right. So the logic again comes in your mind, a very basic logic, because how the postnet works, how your brain's postnet works. Like, can you ever messed up, right? At a very initial moment, at a very like in our when we were very young, right? When we are very young, we used to often mess up in between the left and right. Which one is left and which one is right? I used to mess up in my childhood, right? Then I just remembered it, like I have this red band in my hand. So in the hand where I have this red band is specifically my right hand, and the other one is a left hand. This is the hack by which I used to remember in my childhood, right? So what I did, what I taught my brain, I taught my brain simply, see, this is a red band, and this red band is the pair data with right hand, means red band plus right hand equal to the direction is right. No red band plus left hand equal to the direction is left. So the simple pair I have made, and I have taught this pair to the brain, and the brain recognized this lifetime. So the same logic we will be using for the pose estimation, because it is a logic that we utilize in the PostNet model also. PostNet is specifically a deep learning model. We are simply calling the weights of the PostNet model. I will be detailing it later. Right. So what is very baseline or a ground level approach we are doing? First, we are specifying the objects of the body. So whether it is nose, whether it is ankle, whether it is knees, whether it is hand, whether it is left and right shoulder, etc. Then I am simply doing what? Then I am simply making some pairs. That means this is for this, this is for this. For an example, first I have simply defined it with some value indexes. Okay, then I'm simply making the pair. Now many of you may ask why neck is going with right shoulder as well as the left shoulder, right? So neck is not only with right, not only with left. It is present in the both the cases, so it is a common pair, right? So in this way, I have to make the pairs of each and every attributes and objects, right? I will be making a very basic pair with each and every attributes and objects. So pair making work is done. Okay, so now I have to analyze what is the obviously the height and the width of an image, height and the width of an image, because that is the most important thing for extracting the coordinates. Because if I don't know the extension in the x and y axis, I cannot extract out a particular objects that I am trying to detect out. Then I will be simply calling a very basic loaded deep learning model. Now I have told the logic of you to you guys yesterday, like how to store a model and call it any way you need to use it. That means like you need to store it in somewhere, like suppose yesterday's model we had stored a decision tree classifier in a pickle model, right? Pickle model, like how we stored it. Simply first we written a script that is train.py, simply run the script, and the script is finally being stored as model.pkl. Okay, model.pkl. Then we are simply calling the script in the Flask API, and we deployed it in the front end website. The same thing we used to do. Likewise, another very basic example, many of you might feel pickle, pb, dlib, joblib, many packages to store the Python scripts are present over there. You might feel what is actually happening. What is actually happening is something like this. Like I have told an example yesterday about if you don't like any subject, then you used to what you do, forcefully press in your brain and then simply vomit out in the examination hall, right? Another example I am giving to make these things very crystal, very much crystal clear. How to do very much crystal clear? Like something like just understand some human innovations. Like human innovation, just go back to nomadic era. Like when we are just nomads, like we don't want to carry big objects. Like when it was in the nomadic era, so people used to use big, like tied up the big objects at their back and simply snatch them out, right? It was a very tiresome work. So it created an innovation of wheel. People innovated wheel because people don't want to do the same job every day, and it is also very much tiresome. So they did a simple, very basic innovation where they stored the entire labor. Only they need to move the wheel, and their output will be the same, right? The output previously was also to moving an object. Output in this case is also the same, but yeah, what is the difference? The way they are applying it. So the same thing also used in artificial intelligence. It's not the case like we always train a model. We don't always train a model. What we do, we used to write logics. So there is a way, there is already a trained model that might be saved in any pattern. Maybe it is model.pkl, maybe it is model.pb, maybe it is model.joblib. Like you have to see the extent and accordingly you need to input the package, right? That the same thing you need to do, and you need to see which kind of model it is. Whether it is a CNN model, then you have to write net equal to cv.cnn. If it is an RNN model, then RNN. It is, if you see here, it is a DNN model. So DNN, the same thing you need to do and call the pre-trained model. Pre-trained model. So the same work I had did over here. I have used simply a OpenCV function. It is simply importing a pre-trained model from TensorFlow, and the model name is graph.pb. So now many of you might feel like whether this will be directly importing it. No, anything is not imported over internet. You need to download this file that is called as a graph.pb or suppose model.pk or anything, and you need to input the path. Download the weight of the particular the pre-trained model in your operating system and simply call the path. The work is done actually. So the same thing you might be doing also when we used to work in companies and we need to give a project in a very short time. We don't always make our own deep learning models, or we don't always train our own deep learning models. What we do, we used to customize a pre-trained model based on our logics, right? The same thing we did over here. So we are calling a postnet model and simply doing it. Now, just for your example, what do you mean by TensorFlow? TensorFlow is something like, just go back to your classroom days. So when like it is a difficult examination and a very difficult examiner, you cannot turn up, like you cannot turn around your head and tell your friend some kind of answer. So what the people used to do, they used to tear up a very short part of a paper, write the answer and pass it back. So it will be also about a very rear backbencher, right? I'm not inspiring you guys to do this kind of things, but yeah, take it as an example. Okay, so yeah, this kind of thing is to do. So just understand what kind of computation is happening inside the classroom. The computation is very simple. That means a data is flowing from first bencher to the back bencher, right? That means what is the data? The piece of paper containing the answer. Okay, so the same thing is happening in the classroom. The computation is the data is flowing from first to last bencher. So that has the same logic is being based on TensorFlow. Tensor is nothing but some kind of data points. I'm not going to very deeper of that. Tensor, when it is being flowed, that means something like a data flow. It's called the very basic idea of TensorFlow. Again, some deeper of that, TensorFlow is an open source machine learning library. It is completely written on C++, and it is being trained. It is being created by using deep learning models, right? Yeah, TensorFlow is like something called as the future of machine learning because it have a very strong GPU at its backend. Like it is very much computationally advanced. it can store any sort of model. It can it will be giving you some sort of backend as well, because right now TensorFlow is running in a very advanced generation where it is supporting Android as well as it is supporting for JavaScript, right? So it also supports Node.js at its backend. So this kind of advanced things TensorFlow supports right now. So the same thing I'm doing nothing. A pre-trained model is being stored on TensorFlow. The pre-trained model is DNN model, that is TensorFlow. So through this function, I am reading a pre-trained model from TensorFlow. That's it. Okay, so it is done right now. A model is passed. Whenever a model will be passed, it will be passed to this logic, because this pre-trained model will be customized with the above pairing logic, right? So this is a very basic case of in our case, right? So now the question comes, if you need to record your video, so you need to write a very small OpenCV function to record your video, that is video capture. Okay, so it will be simply doing nothing. It will be recording a recording. It will be taking an access of your webcam, right? And it will be opening the particular video in an OpenCV module, and you have to write a very little test case. If the video is there, then obviously proceed with the script, and if it is not there, then obviously stop the script with the error value. That's it. So this is the universal test case. We used to use the same line over everywhere, right? So there is a very simple logic present over here. In the case of image, we don't need to worry. Why? Because image we can directly pass in a Python script, because image don't need any kind of segmentations, because images are already segmented output of a video. What does this line mean? That means if you need to, you are just your these things you used to do in everyday life, like you are watching a movie and you liked a screen, and you liked a particular scene. Suppose you liked a particular scene or a particular moment in a movie, you used to take a screenshot of the particular thing. So in the screenshot, it is giving you an output of an image. So image is specifically nothing but a segmented output from a video. So in the image, we don't need, when we are passing an image, we don't need this kind of things, because it will can be directly passed to a Python script, and it can involve in the above said computation. But yeah, when we are passing a video is again a collection of number of frames. A video is nothing. Video is having a number of frames. We need to read each and every frame to extract out the logics, right? Because a video, we cannot process the video. But it's the way of video processing. Like for your little example, like many of you might be feeling like, how can I process the same script with the video, or how it is processing actually? You are telling only for the image. So the processing of the image and video is same, but is an additional thing. When you're inputting a video, you have to write a 2 or 3 line additionally that will be simply segmenting out the video in some frames, right? So what does this means? Again, you don't need to write any big logic for that. There is a inbuilt Python math package present, which is called as the H65, or sometimes we can segment out the particular videos by using HSV module. Okay, HSV module. So it will be segmenting a video into frames automatically. So now the each and every frame will be passed. That frame is nothing but an image. Again, the image will be passed to the computation, and then again the output of the computation will be shown in a video. That's the way. That's the way. So the way is very simple: converting a video to image and then process it into the computation, right? So the same thing we did. We extracted out the frames out of it, and again, when we are extracting the frame, a frame is again an image, and if we need to understand the coordinate value, we need to understand the x and y, that is height and right. So we are done with that. We are done with that, the frame processing. Up to this particular thing, we are done with the frame processing. And now what I have to do, I have to follow a logic of blob detection. So what do you mean by a blob detection? This is a very easy question. What do you mean by a blob detection thing, or what do you mean by this particular function that is called cnn.dnn.blob from image, right? So specifically, I guess everyone knows, like when we work on TensorFlow object detection API, or when we work on YOLO v3, I guess this kind of data sets everyone have heard. If you even not heard, then don't worry. It is completely a data set based on which a pre-trained model, based on which a model is trained, and we call the entire structure as YOLO v3. YOLO v3, YOLO v2. There is some kind of advancements, right? So what things this data set is actually having all about? It's having all about some predefined objects. That means if you are trying to define any ball, there is something present in a data set, that means some images of the ball is already present over there. So what you need to do is you need to only call a particular pre-trained model, load in your script, and pass an image to detect. So this kind of things are already present. Like in the database, already a pre-trained model is working at its backend. You need to simply call it. The same thing we are doing over here on our image, because we had already distributed an image into some very small objects which is being already defined over there. So we are defining, we are simply passing it, right? We are simply passing it everywhere. So the next very question is, like, now we are passed with that. That means how the logic is being processed of. The logic is being processed of very easily. Like first we are inputting an image or video. If we are inputting a video, the video is being further classified in some sort of frames. Finally, it is an image. When we are passing an image, first we are doing what? First we are following how our brain works. We are simply defining the attributes and an object of human body, and simply we are doing nothing. We are simply first defining the each and every object, and then the defined object is then passed into some pairs. Because how to understand the why understand a pair, because in our real life also, if you need to understand a direction, you need to go for a paired logic. For an example I've given right now, so we had similar objects with a similar pairs. The same thing we did when we called our pre-trained model from TensorFlow DNN. The model is DNN specifically. We first loaded the model, and then when the model is completely passed, then we had simply did what? We had simply passed the object detection API. The object detection API, that is the cv.dnn block from an image, right? So it is simply detecting the objects that is being hidden over here in this particular function that is called as a body parts. It is doing nothing. It is using an object detection and detecting an object. When now the object detection part is done, when the objects will be detected, by the API, now there might be a logic. How the detected object will be finalizing that this is the real object. This is nothing wrong. How? So here I am not going any advanced logic. I will be simply using a logic of, again, a color mapping. Again, a very simple logic of color mapping. Now here the color mapping is not like yesterday we will be extracting all kind of colors, because I guess everyone know that basic logic, like entire thing that is present in our real life is also simply all about R and G and B, RGB, right? So the distribution of these three colors speaks about everything. Even if you need to create your own color also, in Microsoft Paint you can see something like RGB. You will be seeing some RGB values, right? So how to extract the only and only RGB in a developed manner, like with a complete distribution? If I will using a very simple RGB extractor, then it will be simply telling out the amount of the values present. It will be not distributing or writing the values on a particular object or a complete particular object. For that, I guess everyone knows about heat map. So I will be simply calling the technique from the heat map and extracting the heat map. The particular heat, it is doing nothing. It is specifically each and objects which is being detected will be passed to the heat map. Now it will be matching the two particular present color. That means the thing which is already detected, whether it is a perfect thing or not. Okay. So now it is detected all kind of thing. Now when it is detected, now it is very much sure. Okay, like what object I have detected by the object detection API is the same object which is being present in an image. So now it is done. Now again a question that comes in your mind. Okay, color detected, object is being finalized. Now how can I teach my model that is this is the range of any object? For an example, this is my arm, right? A machine learning script will be, when a heat map is extracted, a heat map is not extracting a thing for only a particular object. It will be extracting a thing for an entire frame. That means this everything. So maybe this is not a perfectly being visualized on a heat map. It is only securing like the object you have detected is the correct one. Now how can I specify the point? Up to this is only the hand. Like when you will be drawing the pose, that means when you will be drawing the line, up to this you need to draw, not like this and this and this, right? How can you tell this? How can you tell this is my hand only? I don't need to extract it somewhere else. So how can you tell this? So this is a way you need to specify again. some range, that is which is the maximum point and which is the minimal point, maximus and minimus. So how can you tell it? How can you specify the object which is being present in a frame, the maximal minimum? Suppose consider it to be a x-axis and y-axis, and suppose it is an object present over there. How can you detect this object range is over here only? So suppose there is an object like this. How can you detect the object range is on here only? You will be simply specifying the coordinates. So I have to write a logic, by logic with a logic that will be extracting out its coordinates and simply calculating its maximum and minimum. That means which is the range, right? So I have taken the help from my predefined frame width and height. That means which is being already defined by me, that is image width and height, and I have simply calculated out of the object coordinates, that is being detected object coordinates. Detected object coordinates, why? The coordinates which is being already verified by the heat map process, because the objects which is being verified by the heat map process are the objects that is actually detected, right? So then the detected and the confirmed objects are passed to the coordinate extraction. Now the coordinates are completely extracted. When the coordinates are completely extracted, now you need to draw the line. Draw the line means suppose from this, and from this, because that is a pose line. Okay, it will be telling me this is the pose of the particular people or a particular image, right? This is a pose in which the people is standing. How to draw this? You will be taking a help from a single line. But again, the logic comes in your mind. Okay, I have detected what? I have detected the object. I have secured this object is the proper object that I want to detect, and alongwise I detected this is the extension of my object. This is my complete extension. Okay, like up to this, it need to be detected. It is detected. Now again, a question comes in your mind like, okay, now I need to draw the line. That means up to this and this, like so. Now if you are directly drawing the line after detecting the coordinates, it may draw a line from this to this, or this to this, or this to this. It will be a distributed pattern because it don't know which is left and which is right. Now you have to define which is left and which is right. How can you define it? It will be simply defined by the pairs that we created above, right? We have simply created some sort of pairs that we will be simply passing it in a function. I guess here the functions you can read. It is simply passed from above. Now it is done. Like, okay, it is understanding this and this for this pair, this and this for this pair. Accordingly, it will be drawing for neck and for neck and left shoulder, this and this only. For neck, right shoulder, this and this only. For this to this and this. In this way, a distributed lines will be drawn and attached. So when it is done, the next very important line is obviously points, because we will be drawing the line not continuously. If you want, you can. That's it. And finally, we need to show. We need to show what we created after drawing the line. So how to run this particular project? Yeah. So again, copy and pasting the particular path. Finally, yeah. So I have an image of like this. This is an input image of mine, right? I have this particular image. So I will be passing the path of this image to my CLI. Python open post.py. Yes, it is image dot. So you can see the pose estimation result. I guess it is clear to everyone. I guess it is very crystal clear to everyone. Or if you have any question, just shoot it right now. If you have any question, just shoot it right now. Or you can test this with any type of image, right? You can test it any type of image. You can also pass your video by using video at your live webcam. If you need to pass it with or given an access of the live webcam, then you need to open Python open post.py. If your webcam is working on your laptop, then just only run Python open post.py. It will be taking an access of your webcam and giving this pose estimation results. Right? Clear? So can I proceed with the next things? Can I proceed with the next things? Please explain the code once. Okay. So yeah. So first I have did nothing. I have simply imported my packages as OpenCV NumPy to deal with the mathematical computations, as I have right now told, entire kind of images at this backend are simply the number values. Next, I want to pass the image, video, etc., as an argumented format. So I have passed this Python package that is called argparse. Then I had did nothing. I have argumented the value for to input an image, what thing I need to write, to input the threshold value, what thing I need to write, blah blah blah. It is done. Now coming to the logic part, what I have, what I want to did, I want to first define the objects which is being present over the body. So what I had did, I have simply specified the index for each and every object. Based on an index, I have defined everything. Then I have told like how can this machine learning model will understand this to this, like this is coming in the left and this is coming in the right. So for that I have created the pairs of each and every object, right? I have simply created the pairs of each and every single object. So the same pairing parts is done on the post pair section. Obviously I am inputting any sort of image, so I need to have its height and width. Next, importantly, because I am using a postnet model and I am not training the model completely, so I am calling a pre-trained model from TensorFlow. The pre-trained model is a DNN pre-trained model. I have trained it. Now, suppose I need to deal with this project with with webcam, that is live stream video. I have used a particular OpenCV function, CV dot video capture, CV2 dot video capture. It will be inputting the video and distributing the video in some short frames, right? It will be distributing the video in very short frames, and the frames is again some images. It will be passed. When it is being passed, the image is present over there, right? Then finally I need to do what? I need to call an object detection API from blob detection, right? It is a pre-trained model that will be detecting an object present on an image, right? So simply cv.dnn blob from image, I will be simply passing it. Okay, then when it is passed, the objects are detected out. Now I need to make sure the object that I am detecting is correct one, it is nothing wrong. Then what I have did, I guess everyone knows the image is simply something defined by R and G and P, RGB distribution, right? So simply you need to do what? You need to extract out the particular heat map, right? You need to extract out the particular heat map. So this heat map will be simply matching out like which one is the perfect one and which one is not the perfect one. So when it is confirmed the detected object is the perfect one, right? So then how can you tell this the range of this end is only up to this, not up to this, or not up to this? You need to specify the coordinates, like coordinates will be telling the range, like up to which is being extended out completely. You are done with the coordinate fixing, and then finally when you are done, you need to draw this kind of line. So how can you draw this kind of lines over there? So for that you need to do nothing. You need to call your again above, like describe the pose part. The pose will be telling the neck is going with this left direction, the neck is going with this right direction. It will be simply calling it and finally drawing the line below and showing it like that. So this is a pose estimation, not by training you an algorithm. It is a pose estimation by everyone. Simple, easy, understandable script, that is OpenCV. This kind of short projects you can apply. You this kind of, if you're applying for any kind of fellowships or any kind of internships, this kind of short projects actually matter much, because these projects are something short but interesting or something valued. This kind of things you might do, right? So any other question? I will be proceeding with the next part. If you have any other question, you can shoot. Otherwise, we'll be proceeding with the next part. So another project pose estimation is done. So now let us have it another project, because computer vision is something interesting. I will be coming to that. But before that, let us come with some logics and theoretical sections. Again, not theoretical, but yeah, we need to follow it completely. Okay, right. So we will be starting with the left algorithms that we have told and promised you guys, that is SVM and PCA today. The most important ones, SVM and PCA. Support vector machines and as well as the PCA parts, because this is something that is mostly required, and I will be also telling about the projects. I guess now you guys can at least deploy your own projects after this. Don't know, but yeah, maybe. Okay. So yeah, so what I have to do is, what I am doing something like this. What do you mean by SVM, or why SVM is why SVM is so much of famous, or most importantly, logic about machine learning. Now again, SVM comes under a classification model. It is also used for prediction, detection, etc., etc. But yeah, it is mainly used for the classification cases. For example, if you need to, for example, you are making a project that is called sentiment analysis. So you are making a project that is called sentiment analysis. You can make the project by using an algorithm called as the SVM. How? Because in sentiment analysis, what we do is sentiment analysis. We simply take an input text and classify it into proper sentiments, whether it is telling about any positive thing, negative thing, or neutral thing. The same thing we used to do. So the logic is again something called as the very basic classification problem, right? Very much basic classification problem. So now the question comes, or now the logic comes something like this. Like, okay, I understood what do you mean by classification, what do you mean by everything. Now come to SVM. So what we have learned on the previous algorithm, decision tree, linear regression, or logistic regression. I am leaving linear regression for right now. I am telling about LAR, holistic regression, and decision tree. Decision tree is if you need to take any decision. That means if you need to classify an object also, you have to have you might have some parameters, and the parameters really control your output. So what are the parameters? If you want to have that kind of outputs that will be controlled by the parameters, decision tree is the best way to go out. And logistic regression, I have told, suppose you are having a fixed range, and inside a range you need to run the classification, or you need to predict anything. But covering most of the data, you can go for holistic regression. So now question comes, why the logic of being SVM is being there. So let me again draw a very basic diagram, and let me plot two types of data over here. Right, like I am simply plotting two types of data. Suppose this is the data number one. Data number. So suppose we are taking a very simple case of the data distribution, like how the data is being distributed. We are taking a very simple case of the particular data distribution. So now the question comes is, okay, the data is being distributed. I can see it in the exploratory data analysis, how the data is being distributed out of it. So now the question comes is, okay, what is the problem you are dealing actually? So I am dealing nothing. I am dealing, suppose, let us take an example. This is a problem of sentiment analysis. This is a problem of sentiment analysis. And in this very basic problem of sentiment analysis, I will be having input text, and I need to classify the input text on whether the input text is having positive sentiment or whether it is having a negative sentiment. So this is my input data. I have simply, or this is my training data. I have simply probabilized this training data or distributed this training data in this manner. Right. For an example, X for positive, green for negative. I guess I have okay, and red for positive. Take the reverse case. Actually, it should be X for negative, and green for positive. Right. Okay, take the reverse case. Okay, we are not so much color valued. Okay, let us say now I have simply distributed my data like this. So again, come back to your childhood. So what happened with us in our childhood is like, from childhood or in our entire life, the persons who are very close to us have a great influence on us every time, because we only follow the persons who are very much close to us. Like for an example, if you guys are listening this session properly and if you guys are getting inspired of machine learning, then you guys will be following machine learning. That means something which inspires us, we used to follow it. Like our upcoming days is being controlled by that particular inspiration. Okay, so this thing happens with us. So my question is, if this happens with us, so why cannot with machine learning? Yeah, it happens. Then this is a very obvious and actual case what happens with support vector machines or SVM, right? So before coming to the theoretical part, let us understand the scenario more and more properly with the 2D data, then with the feedback. So yeah, what happens specifically now come back to the particular question. Suppose suppose there is a you are walking in a road and someone is using some kind of abusive languages, and you listen the particular language. Obviously the person will be telling some language in a particular sentence. Okay, so the sentences are coming in your ears, and the sentences are coming from ear to your brain. So how your brain understand this thing is negative, this is not anything positive to our society. How can your brain understand that? So your brain simply, maybe your brain is using some kind of algorithm. So we need to find out what algorithm your brain is actually using. Actually, brain is an amazing thing, and entire thing is being on brain. So yeah, how your brain can analyze or understand this is the thing the person is not doing right. So we can think like this. Maybe the brain is first distributing the sentence in some words. That means the sentence is like having you are beep 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 dash, right? A full stop. You are beep 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 dot. Okay, this is the sentence. And your brain have simply classified the sentence in a manner you, a word, are, a word, beep, a word, beep, a word, beep, a word, beep, a word. I guess everyone can understand what do I mean. I try to mean by beep. Okay, this I guess this might everyone can understand. Okay, so in this, so at a very ground zero level, maybe your brain have like inputted a particular sentence and divided it into this kind of words. Then a brain maybe our brain may be calculating how much beeps are present over there, right? Beep, how much beeps are present over there. So the number of more beeps, then the thing is negative. Number of less beeps, maybe it is positive, or no beep, obviously positive. So maybe this kind of calculation brain is doing at its backend. So in a single sentence, if I am asking you what your brain is doing, how can you analyze? How can you tell it? You will be telling it more amount of the data or more data, or the data which is nearest to our probability is controlling the output. Right? So the same thing is happening with SVM also. Like for an example, SVM is not like logistic regression. It's not like logistic regression or linear regression that it will be simply passing with a limited amount of the data. The line of SVM is specifically called as, for an example, I'm drawing a line like this. For an example, I'm drawing a line like this. Okay, this is a classification line. This line is specifically called as a hyperplane. Hyperplane. Okay, so this line is not static line, because in linear regression you have seen it to be static. In logistic regression you have seen the sigmoid curve to be a static one. But yeah, it is not a static in this case. It can move. Now the question comes how it can move or how it can predict, which is the most classified output. So obviously it will be calculating more amount of the data, right, that might be controlling the output, right? Or it will be calculating some more amount of words that is present in a sentence that will be telling whether the person's sentiment is positive or whether the person's sentiment is negative. There might be anything like this. So yeah, there is. How can it calculate? So it will be doing nothing at a very base level approach, or at a very initial level approach. It will be using the logic of the nearest one. That means how can it say which amount of the words is present in a more fashion, or which amount of the word is present on a greater fashion, right? So simply what SVM used to do, if I'm making it explaining in a very single line, then it will be drawing a hyperplane. It will be choosing a hyperplane. Choosing is a part of SVM. This hyperplane will be classifying data into two parts. Maybe some amount of the data is present, some amount of the green data is present over this side also. Maybe some amount of red data is present on this side, because data is distributed. But it will be telling which part of this hyperplane having most section of the data. That means suppose, or which part of the hyperplane is covering the most of the part of the particular curve. This is the very first step of the hyperplane. So I have tested with this particular SVM with this case only. So if you are understanding with this particular enclosed area of this particular curve, then you can see the maximum portion of this is completely green, or the maximum portion of this thing is green data. So my output will be negative sentiment. So the same thing SVM do actually with the data. That means again the question comes, like, again, can you please more be clear? Anyone, many people can tell like this. So SVM works in a very similar fashion. First, yeah, I'm not telling the hyperplane is static. I'm not telling it is a single hyperplane. You can choose the hyperplane, you can choose the coordinates, alongwise you can plot it out. But when it will be plotted, how it will be judging, which is your sentiment, how the model training takes place. Model training takes place with a very basic output of like which amount of the data is present at a higher extent at the biggest area, or at the enclosed area, at an enclosed area. Why we are not considering this area? Why we are not considering this area? Because this area cannot be enclosed. This area cannot be calculated. If you are using a power of integral calculus also, you only calculate the enclosed area. That means integral of y dx. Suppose you are using to calculate the area, then you will be calculating the area, only the enclosed area that is enclosed inside the curve. And the enclosed area, the amount of the data which is being present at a highest extent, that are enclosed data, is obviously the data which the SVM picks, and it is the data that controls the output of SVM. And SVM is something very advanced algorithm. Even SVM works in the very difficult cases also. High level NLP also SVM functions. So yeah, it's all about a very basic line output of the idea about the SVM. I will be not going very much deeper about it. Only for a beginner level, after this it will be very clear. So we are doing SVM. I guess the logic is clear. Logic is clear. You can tell on the section. So next after SVM we are done with SVM. So like I just writing a summary of the SVM. It is hyperplane selection is the very first work. Next work is the area approach. Which area? And enclosed data in the particular area. And finally, when the data, when I can just cover up particular enclosed data, it is simply classifying the data. So it is majorly and primarily a classification algorithm. It can also predict out that, but yeah, it is majorly and primarily a classification algorithm. So yes, so I guess there is no query out of SVM. So we can proceed up to the next. I will be just hitting the most important things. Most important things. So let us come to the next important algorithm, that is KNN. KNN. K nearest neighbor. K nearest neighbor. Okay, so the K nearest neighbor algorithm is like something very very important algorithm, and from the very first day of the machine learning, used to speak about this. So K nearest neighbor is something like our COVID-19. Why? Because K nearest neighbor is like this. Like you are living in a locality X. Suppose you are living in this locality. This is your locality, right? It is locality, and it is your house. It is your house. Okay, your house is X. Now there are neighbors around your house. These are your neighbors. That means who are residing beside you, who are residing very beside you. These are the neighbors of you guys. Right? I have seen when this neighbor, suppose this neighbor is affected by COVID-19, no problem with you. No problem, you are. That neighbor lives in that direction. I have no problem. This neighbor is affected with COVID-19. No problem. I am negative. I am not positive. This neighbor is affected with COVID-19. Your voice is getting trembled. Okay, maybe, yeah, maybe the chances are there. We have to take precautions, but don't worry, that never. Still, you're chill out, but yeah, somehow tremble. Now, This neighbor, very close. Okay, precautions we need to increase. Now the case is serious because the very close neighbor is being affected. And now finally, this neighbor is affected by COVID-19. Then similarly, you will be also affected by COVID-19. You have seen my very nearest neighbor is affected, and I am also going to quarantine with him. So this is the case of computation of k nearest neighbor model. The actually COVID-19 is following k nearest neighbor. If researchers might have solved the k nearest neighbor, they might find out the problem of the COVID-19. Right. So this is the case of the COVID-19. So if you need to save yourself from COVID-19, then read the logic of k nearest neighbor. Right. So it is the most important algorithm. So how now to understand how in machine learning it works. So in machine learning, it's something like, again, I need to draw a diagram. Understand everything diagrammatically if you are least interested in mathematics. Right? I will be telling you guys at least read the backend mathematics, so you will be something good or something good person in machine learning. But yeah, if you still badly want to be in part of this MIML, then just understand everything like with the real life examples. It's actually very easy if you understand. If you're not simply mugging up, then scenarios may be very pretty difficult. I'm simply plotting two types of data. This is the data one. This is the data two. This is the two types of data which I'm trying to plot, right? And what I'm trying to predict is, suppose again, let's take an example of COVID-19. So suppose I want to do the COVID-19 prediction, and in my COVID-19 prediction problem, I am using a model called as the KNN, K nearest neighbor. So how can we do the K nearest neighbor? How this K nearest neighbor works? I've done that with nothing. I have simply plotted the data, positive and negative. This is for negative, and this is for positive cases. Positive cases of COVID-19 and negative cases of COVID-19. So this thing is actually reality that's happening. Okay. So now you need to predict. Now you need to predict like what will be the probability of the COVID-19 cases for a locality. That means what will be the tomorrow's probability. So you need to draw a probability. So simply, what is the first step of the KNN is to fix the K value. K is the most important value. K value. You might tell K is such a logic that is similar in K, then that is similar in K means, that is similar in K mediodal, that is similar in K modal. Four algorithms comes under this K value. K value is the most important logic. I am not explaining the K value in theoretical or any technical understanding. Just understand one thing, what do you mean by K value in machine learning? K value is such a value, just analyze this example very carefully. It's something like if you are like, we all used to live in a home, and there is someone in a home who used to speak the last decision. Maybe it is our father, maybe it is our grandfather, maybe etc etc. So the person is someone who used to speak the last decision. Then if you are a machine learning developer, you will be naming the person K value. You are K value, right? So this is what? This is the value, this is on which the output depends. This is the value which controls the output. This is the value which controls the prediction. This is the value which controls the probability. Right? So K value. First I fixed up the K value of my data. So suppose this is my particular K value. This is my K value. Now what will be the next step? The next is calculate the nearest neighbor. Which one is the nearest neighbor? Which one is the nearest neighbor? So how to calculate which one is the nearest neighbor? Simply calculate out Euclidean distances. Euclidean distance, how to calculate? Suppose you need to calculate the Euclidean distance from this point to this point. What will be the formula? Root under, I'm writing like this. I'm simply telling the formula. Root under x2 minus x1 whole square plus y2 minus y1 whole square. Coordinates you have, only you need to do that. So the same thing you have to repeat with everything. Right? You have calculated the Euclidean distance. What will be the output you will be showing in your seeing in your script? You will be seeing a very basic output of a minimum function. which one is the minimum list of the values of the distances. List that will be having the values of the distances. Suppose this is the list D equal to the Python list. Suppose this having value, and this will be having in your output. Okay, we'll be having this in your output. What will be the next step to implement KNN? I'm telling the implementation scripts only, test implementation stages only. I'm not going into theoretical parts. So when you are having the list, just implement the Python minimum function, min function, min function. It will be returning the minimum value out of the list. So this minimum value, how now a question may come into my mind. I have to find out the minimum value. How to find which of the element is corresponding with this minimum value, with the element. So how to find how to find this element from this distance? You have to simply use the logic data structure and algorithm. Like sort an element by its index. Okay, so here your sorting parameter will be distance. Based on that, you will be having an index, and based on that, you will be simply telling which in particular neighbor is the nearest neighbor, right? So the nearest neighbor, if it is positive, obviously I can see the nearest neighbor in our case is COVID-19 positive. So the output will be coming positive. So that is how a KNN used to work. That is how a KNN works, right? So this is the very basic architecture of working of KNN. So just I'm telling an algorithm of a very basic project, very basic project to you guys. Just a very basic algorithm. This is a very basic project of detection. So how detection works? The project I'm discussing, I'm not implementing this project. This project is suppose you are making a project in class CCTV. So this CCTV will have the power of detecting passes. Like passes means it will be obviously recording a video, and it will be telling how the students are moving the papers. That means how the students, suppose this CCTV will be telling like CCTV will be playing or CCTV will be detecting. Suppose there is an examination hall. In an examination hall, how students will be simply passing some scripts of paper. That means there is cheating going on. The CCTV will have the power to detect the cheating. So the project name is cheating detection system, right? So how to implement this project? By using the power of KNN. Only simple KNN. I am not so much complex person. I will be using simple KNN. How? So I will be doing nothing. First, record the video. Then when you will be recorded the video, or recording the directly using the webcam stream, the video using OpenCV, I will be like the same script before. I will be simply dividing it into some frames. Frames means the individual images, right? Individual images. So now what you have? You have some images. This is an image. Student is sitting like this, another student is sitting like this, another student is sitting like this. So in this way, suppose the students are sitting in a particular image. So, and here is the paper. Here is the cheat paper being passed. This is the cheat paper. Okay, this is the cheat paper which is passed. It is suppose frame number 1. Now in the very next frame, this is the frame number 2. Again, this is the student. This is the student. This is the student. And now the thing is here. That means the cheat number is here. The cheat paper here. Frame number 2. That means from frame number 1, the image is passing to frame number 2. This is the case. How will be tracking? How will track how the papers is passed from one frame to another frame? How? So it will be very easy if you calculate the nearest distance. When you will be suppose in the frame number 1, the very first step you have to do, you have to extract the coordinates of an object. That means what are the objects present over here? This, and this. A person and a ball. No, a person and a particular piece of paper, right? So you are done with the detection of the particular thing. You are done with the object detection part, and now you have the coordinates of each and every object. So what you have to do, you have to calculate the minimum distance by the KNN. We'll be writing a script code knn.py. KNN will be calculating the distance from the paper to the particular objects. Object number 1, object number 2, and object number 3. It will be simply calculating the distances. Suppose the minimum distance out of this returned by the KNN with the object number 1. So the logic is very simple. The object with which it is having minimum distance, that means that particular person is carrying the paper. So who is cheated in frame number 1? And the thing is shifted to frame number 2. That means here you returned, that is the minimum distance of the paper, and the thing is with the 2. So who is cheated in frame number 2? Who is cheated in frame number 2? Object number 2. So this is the power of KNN. This is how KNN is used in OpenCV. KNN is used in computer vision project. KNN is used in projects, and you can use the power of KNN to do this kind of advanced object detection. Even we use this kind of things. So I guess we are done with KNN. Just a little recap what we have covered today. We have did the pose estimation model. We have created this kind of pose estimation, right? Pose estimation, this kind of thing. We have learned SVM. We have learned KNN. Along with have discussed the object detection project by KNN. Now, after learning PCA, we will be implementing object detection. I guess we can start with deep learning tomorrow, because today it will be really heavy if we start deep learning. Just I will be giving a very little example of CNN only. Only CNN we will be covering, and a very short project on CNN. Right, so that will be, I guess, but it will be better if we deploy the deep learning tomorrow. So now the question is the code of OpenPose is available? I will be uploading it, right? I will be uploading it. The GitHub link remains same. I haven't uploaded the previous codes also, like the previous days classes also. So I will be uploading on the same link. I'm just sharing the same link. I will be uploading over here. It will be come to my GitHub. I will be uploading it in this repository. ML Bootcamp GS. ML Bootcamp GS. So here everything will be uploaded. Right now I haven't uploaded because just for a little pressure I missed up. I will be uploading everything today. Right? Everything will be uploaded maybe today. So okay. So here, so the next important algorithm that we are going to cover today is the PCA, principal component analysis. So principal component analysis is something, is like the logic is very similar like a topper boy of a class. So like again go back to your classroom days. So what happened in our classrooms? The person who is the topper actually, first the teacher enters the class, topper will say, "Hello, sir. Good morning, sir," and his word should be considered as like as Lavani's of Gita. So this is the actual scenario in our education system, right? So those toppers are present over and listening my session. Don't take it on you, but this is an example. Don't write home. Okay, so yeah. So now the question comes, the topper is moderating the entire class, right? Topper is moderating the entire class. The same thing is also with principal component analysis. A principal component analysis, SVM, this kind of models are very advanced models, because this thing comes under the very foundation of deep learning as well in any script, whether I'm writing a CNN or whether I'm deploying a computer project. As a side script, I can use this kind of models to increase my accuracy. So these are very important algorithms. These are very important. Likewise, an example I right now showed you guys. It is an example from OpenCV, but how the tracking we can do by KNN, which just adds some kind of accuracy to my project. So yes, that kind of things matter actually. So now my next algorithm is PCA. principal component analysis, right? So what do you mean by principal component analysis? My class cut topper, right? So what is this? So a topper is moderating entire class. So what will happen in machine learning? The most important data point will be moderated output. I will be say very salary type. Most important data point. How you mean most important data point? What do you mean by most important data point? The most important data point is a topper can moderate a class, or suppose the person who can moderate your life, or a person who can change many people's life is actually a leader, not a boss, right? So who is a leader actually? A leader who have somehow similarity with the other employees. Suppose I am running an MNC, and I'm running an MNC, and I am the leader. I'm leader. When people will call me leader, when I will be changing many people's life, or when I will be inspiring many people's life. The question comes: how will you inspire others' life? So again, the answer is there in your brain. The answer is there in your psychology, working at its back end. So what is the psychology to of the leader? That means you feel some connection with the particular person. Okay, this person and I is somehow connected, or there is a good communication in between you and the particular person. You might feel when there is a good communication, when there is good connection, there is obviously some similarity. We always talk with those persons who are similar like us. Obviously, I am not going to talk with such a person whom I cannot connect, whom I cannot relate. And when I can relate with someone, the person, that means I have similarity. And that is the actual case happening at principal component analysis, right? Machine, again I'm telling, machine learning, these things is entire, like all answers, the entire machine learning, whether you are going to computer vision, deep learning, generative learning, maybe the coding part you need to learn, maybe how to write language you need to learn, but you need to understand AIM, or if you need to deploy your own projects or create solution, you need to first understand your brain and first understand the real life scenarios. So for example, right now I have told is connection. So the same logic has used by PCA. Why we are simply freaking out? Again, let me plot of data. So this is my data. Suppose another data. So there's three types of data is being there. So data A and data B and data C. It's the three types of data, and I need to have a prediction. So how can you have the prediction? And you are using an algorithm called as PCA. How can you have the algorithm? How this algorithm will function? I guess everyone knows like how suppose this data are simple numerical features. So A equal to feature one, suppose, or A equal to data one, C equal to data one, B equal A equal to data one, B equal to data two, and C equal to data three. This is the three types of data. So how PCA will be showing you an output? How? It will be calculating the similarity index in between each and every data. That means it will be calculating at the back end how much the two features are similar to each other. Maybe it is using some kind of sorting logic, or maybe it will be using some kind of matrix based computation logic that is back end. I'm not telling which kind of logic or which kind of mathematics it is used, because there are some kind of mathematical theorems that are back end of PC. I am simply telling the visuals that you want to see. The visual is it will be calculating which particular data point is similar to other. How? It will be simply calculating the similarity index of that particular thing with others. That's it. So suppose the output is here. This is the most similar data with others, and that will be actually controlling your output. Most similar case will be controlling the output in the case of PC. Now there are many things to manipulate and optimize PCA: greater covariance, lower covariance, average covariance. So just understand what kind of mathematics PCA uses backend. PCA use the covariance of any matrix. to calculate the similarity index, covariance of the matrix. But don't worry, you need to implement it in project. So just understand how the algorithm works. So I guess CCA is clear to everyone. Now we can start with the last and final project of today, because I guess I will be not freaking out everyone. Uh, this is the very last and final project of us today by using OpenCV. Again, tomorrow we'll be implementing CNN on number detection, and tomorrow we'll be implementing CNN on. I am trying to implement a facial recognition for you guys. Okay. Otherwise, number detection and facial recognition, the tomorrow's projects are. And we will be learning CNN tomorrow, deep learning basics and CNN. And tomorrow, and at the last day, we will be completely having a career-based thing, project-based and other project opportunities, career-based opportunities. Plus tomorrow and day after tomorrow. Okay. So yeah. So now let's come to an object tracker. We need to track an object. We need to track an object over here, or I need to track an object, suppose. So how to track an object? I'm simply calling again an OpenCV function, right? OpenCV function in CV2, and sys is nothing to input the rate. Don't worry. I'm simply checking the version over here. So first, what I have created a Python function. So now what are this kind of thing? Boosting, MIL, KCL, TLD, median flow, CSR. What are these things? CSRT. These things are the inbuilt object tracker. Like seen in the inbuilt blurring function in OpenCV, inbuilt filter functions in OpenCV, and as well you have seen in how to call the models in OpenCV. Another important thing I'm just showing, it is called as the trackers of OpenCV. This also use the logics of KNN, SVM, etc. Its backend is already pre-trained, and only if you need to track any object, you have to use the power of this kind of tracker. So these are the different kinds of tracker. So boosting, MIL, KCF, TLD, got run, CSRT, median flow. There are 9 trackers in OpenCV. So we used, if you don't have time to train, if you don't have time to write your own logic, you can at least use a tracker. And don't, in AI don't feel like if you are not doing a training a model by your own. It's not always that you need to train your model by your own, right? What is the thing? What logic you are using? Like what kind of logic you are using, or what kind of technology you are going for? Whether you are doing smart work or a bad work, right? Because there are many examples to me. I don't have time to give the examples right now. At the last day I will be giving some kind of examples. I know many people like this who have scored different kinds of things, even started with zero, right? So yeah, boosting, MIL, KCF, these are the trackers. So what I have did first, I have simply defined this kind of trackers at a first, or simply called this kind of trackers. Then finally, since I will be inputting a video, or again I will be inputting an image, and obviously in this case I will be inputting a video. Simply I have called a thing, and then I have written each and every single function. Suppose if I need to call the boosting, then I have written the function for the boosting. CV2 tracker boosting inbuilt data function. Suppose I need to track by the help of MIL, I have simply called tracker MIL create. Suppose I need to call KCF, I need to have simply this. So for each and everything, the functions are created. Then when the functions are created, then I am simply inputting my video. This is my input video. Again, when you are inputting any video, you have to write a very simple if-else logic, right? So if you are very simple if-else logic, because if you are not writing this if-else logic, then whether your video is opened or not, then obviously it cannot read. So if it is open, then obviously proceed with the code and call the function. If it is not open, then game over, right? So cannot read the file. Then obviously for tracking, right? For tracking, like I guess everyone, like whenever you used to see CCTV footage, so have you ever wondered how news channels, when they used to show the CCTV footage, when a criminal is doing some sort of crime, right? So how they used to plot a box on a particular criminal? They're actually using a computer vision. You are seeing like a CCTV footage, and they are plotting a particular criminal there. So they are simply plotting a graph, simply plotting a box to track the particular criminal. So they are using computer vision at its backend. So the same thing we are doing over here. We are simply first calling the tracker that will have the power to track. The logic remains same that I have just discussed some minutes before. Again, inputted the video. Then I am simply drawing a bounding box to track the, or to simply say, set, okay, this is an object. So how can you tell the bounding box will be only confiscated to this section? The particular thing is called an ROI or region of interest which you want to track. Now what you have to do, likewise at the very first project, this project also we need to draw the particular thing on the video. That means bounding box on a video, or like in a CCTV footage, bounding box on the particular criminal. For this is what called in technicality write function. Whenever you come across the write and read function, read means reading a frame, taking a data from frame. Write means when you are annotating on it, when you are writing anything on it. That's it. You are simply calling it, and yeah. So your writing is done. It will be obviously taking a time of particular video. How much time a video is going to run. For that reason, we have simply used the time function. Now the most conceptual part of tracking, object tracking, is FPS. FPS, frames per second. So what is this? Like, just come back to our physics, class 11, 12 physics. So how we used to suppose we used to come across this kind of mathematical questions like Ram is running at a speed of this, and there is a person sitting inside a train. He is running with a train. Then at what speed might train? Some kind of concepts of relative velocity. Concepts of questions of relative velocity. So what happens in the case of relative velocity? Two persons have some kind of speed. So one want to track another person. If you suppose train and person, train have a speed, person have a speed, one want to track the another one, right? So how does the relative velocity concept one minus simply a difference between the two velocities, Vr minus Vi, something like that, or V relative equal to Vi minus V2, something like that. Okay. So what does this actually take in? Frames per second. That means what is an object speed per second, how much speed the object is moving. Because why we need this logic? The bounding box will be also moving with an object, otherwise kaya ka tracking from where we are tracking means the bounding box that is detecting an object, it will be moving with an object. So for that reason the bounding box have to know, computer vision have to know what is an object speed. So how to get that object speed? Simply FPS, calculating the FPS, the same we are doing. Like the total time, obviously this kind of basic mathematics everyone knows, time of the video movement and that kind of thing. Otherwise everything is inbuilt, you need to only call this function. It is nothing so much theoretical, only calling FPS is logic, right? So you are done with that. Now if your tracking is successful, it will be returning a successful and drawing a bounding box, otherwise it will be showing tracking is failure. That's it. So now let us test this code, and then I will be coming to the questionnaire session. Yes, so let us test this code. First, let me complete it. Okay, I guess this thing is being updated right. Just a second. Let me debug this error because thing is updated, I guess, in the new documentation. Documentations used to change, so this kind of things used to happen. Is this a version error? Is this a version error? Let me check. Maybe version error. You can keep on shouting your question. Can you integrate ML with DevOps? Yeah, you can. Like you can use Kubernetes to deploy ML models. You can use Docker to deploy ML models. You can obviously use the both of them as well. Yeah, you can test the ML scripts by using any kind of CI/CD frameworks. You can use that. Any other question? Yeah, obviously, because ML models. What I want to say, if you are storing the weights of any machine learning model, if you are storing the weights, that means suppose you are having a very high weighted deep learning model. For example, Detectron, for example, pose nets, for example, residual net, for example, mobile nets, Mojave nets. So this kind of models, if you want to train the model repeatedly without calling the weights, so you can store the entire architecture on Docker and you can run it off. Otherwise, Jenkins is supporting right now. It is on development phase, but yeah, Docker and Kubernetes is actually very much well supported. But Jenkins CI/CD supports ML frameworks. But yeah, there are still some algorithms which they are not supporting because still on developing, but hope so that will be supported by them. Next question, please. Next question, please. Next question, please. I guess there was a question on yesterday's session also.
Sir, I've just
Next
highlighted the
question.
question.
Yeah, yeah. Okay, what was the question being present on the yesterday's session? Like,
This was the question about yesterday's session. Please explain.
yeah, it's worked. Okay. So yeah, it worked. So I need to track Charlie Chaplin. So I need to draw a bounding box first on Charlie Chaplin. So let me draw him. So see, this is tracked. How the Charlie Chaplin is moved, the entire thing is being tracked. So this is called tracker. You can work with many other videos also. So this is tracker. This is a very low FPS video, but yeah, this is tracker. Here you can see recording of FPS 5 and 6. So I guess logics are pretty clear. I will be uploading the code of each and everything tonight because right, I will be uploading the code of each and everything. Okay. So just miss any other query, please try to ask. Please explain the code of weather prediction. Yeah, weather prediction is something like, okay, there were some previous queries also. Could you say the algorithms used for face recognition in OpenCV? Okay. Okay. So the weather prediction script what we had did yesterday is something like yeah. So first the algorithm that we had used is decision tree classifier. So simply first we had some data of weather prediction. So for predicting the data is having some sort of attributes like temperature, rainfall, etc., etc. Then on the basis of that particular data, we used to pick up the particular training parameters on which I need to train my data. Simply written the script of decision trees and simply train the model by the help of the Python package called as the pickle. Python package called as the pickle. So by the particular Python package, we used to have something stored of the train model that we call as the train dot pickle, right? Then when the train model is done, then I have simply written a index.html, right? In that particular index.html, I have did what? I have simply passed my input parameters. So my input parameters was there on the index.html, like, so when the index.html's input parameter is coming, then how it will be coming to my backend machine learning script? It is simply by using a Flask API, right? It is simply by using a Flask API. That Flask API is simply taking the inputs from the front end file, and when it is taking the inputs from the front file and passing it to the ML script by using a Flask API and simply define functions. Next question. What is tick frequency? Yeah, so what is tick frequency? It's something like, what if you are specifically working on some kind of platforms or some kind of video specifically. Suppose you are working for that kind of video extension. Just a second. Yeah, suppose for an example, you're working in a video of, like, you are working in simply a MP4 video, right? Or you are something in a particular high FPS particular type of video. So why you need a something called as a tick frequency, or what do you mean by tick frequency, and why it is not so much used in your computer vision parts, but yeah, it is still comes under the matplotlib section. So tick frequency will be picking at each and every single objects out of the particular video first, and then it will be tracking the object by FPS. Based on that, it will be plotting the entire curve, and it will be telling how the things are proceeded up in a step by step time. Any other query? Any other query? Any other query?
I think so. We don't have any other question.
Okay. So yes. So let us meet tomorrow then again. Yeah.
Okay, thank you so much, sir, for today's session. And guys, before finishing up, I would like to tell you that we have the feedback form link in the description box. And in the future also, we guys will be doing many such web events on deep learning and data science. So yeah, to stay tuned with us, I request you all that you guys must follow us on our Instagram or on our LinkedIn. The links are given there in the description box, so you guys can go and check them out. And yes, thank you so much for being such a wonderful audience, and I hope that you guys enjoyed it. Thank you.